Okay, now we're going to talk about multiplying and dividing complex numbers. It's a little bit harder than adding and subtracting, but you can do it. So if we want to multiply a complex number by a real number, like 4, here we have a real number times a complex number, it's just what you'd expect. You distribute the real number to both parts. So 4 times 2 and 4 times 5i just gives you 8 plus 20i. Okay, so not too bad. What if you have a complex number, a plus bi, times c plus di? Well, we can do this complicated symbolic thing, right? What we're going to have to do is FOIL, just like we would with any binomials if they were real numbers, if we had x's, right? We multiply the first, the outer, the inner, the last. You could make one of those x things that CP/M teaches you to do. That works as well. Okay, so there's a bunch of symbols here. Don't get overwhelmed by those letters. The one thing we have to be careful of is we have to remember that I squared is -1. Okay, so when we multiply this out, we get a times c plus a times di, a times di plus bci plus b times di squared, right? Because it's I times I. That's what we have over here. First, outer, inner, last. And now we notice that this I squared is going to be -1. Right? Everything else stays the same, but we make this negative because I squared is -1, right? And now that's real, right? That doesn't have any imaginary parts. So we combine these two together. So we have AC minus BD plus AD plus BC times I. I would definitely not recommend memorizing this, right? We just FOIL these out and be careful about the I squared. So you could stop this, pause this, and try to work that out. Let's see if I can move this over. There we go. Okay, so if we have this complex number times this complex number, we're going to multiply the 4's together. And then, then I guess they do this. Let's see. 4 times 2 times 4, 4 times -5. So they combine it in one step here. Okay, I would not do this. I would just say 4 times 2 times 4 times -5i times 3i times 2 and 3i times -5i squared. Okay, so they combine this in one step. That's kind of complicated. Let's just work it out on a piece of paper. Let's see, that was this problem here. Close that so you can see. Okay, so let's do this the way I recommend. If we have 4 plus 3i times 2 minus 5i, okay, so let's multiply these out. We'll have 4 times 2 plus 4 times -5i plus 3i times 2 plus 3i times -5i. So as with most problems, be careful of the negative signs. Okay, so now let's simplify this a little bit. We get 8 minus 20i plus 6i minus 15i squared. You're going to be tempted to skip this step and just in your head say I squared is -1 and change the sign. And you probably can do that, but sometimes you're going to make mistakes. So I would recommend just always writing this step out and writing I squared and not skipping it in your head unless you're really, really good about doing things in your head. And even then you might make mistakes. Okay, so now let's simplify this even more. Let's say 8, let's combine these, minus 14i plus 15, right? Because I squared is -1. So then I can combine these and I get 23 minus 14i. Okay, so there's nothing super fancy going on here. We're just being careful, right? As we distribute, we're just being careful of minus signs and things like that so that we can combine things at the end and have them make sense. Not sure why this isn't flipping back, but let's just do it this way. Okay. So that's multiplying. Let's talk for a minute about complex conjugates. Okay, so the complex conjugate of a number, if we have a plus bi, is just a minus bi. Okay, there's nothing super tricky about it. You just change the sign of the imaginary part of the number. And the real number just stays the same. Okay, so in your mind or on a piece of paper, maybe think, what are the complex conjugates of these two numbers? 2 plus I square root of 5 and negative 1/2 I. So we just change the sign. So it's 2 minus I times the square root of 5. One thing to point out here, notice that the real part, we have this imaginary number here, and usually we write like 2i, right, with the real part in front of the I. When you have a radical, it's kind of convention that you write the radical second so that you don't accidentally think that the I is underneath the radical. So it's not like wrong to do it the other way, but this is kind of the convention. If there's a radical, it usually goes after the I. Just an FYI. FYI, see? Okay. All right, and now we just have a minus 1/2 I. The thing that makes this maybe tricky is there's no real part. Doesn't change it. We just change the sign of the imaginary part, so that would be 1/2 I. Why would this be interesting? Okay, well, let's look what happens if we have this complex number. Let me just go there. Okay, if we have this complex number, 2 plus I square root of 5, what happens if we multiply it by its complex conjugate? Okay, let's multiply these out. 2 times 2 minus 2 square root of 5 times I plus 2 square root of 5 times I minus I squared square root of 5 square root of 5, right? You could write that just as 5 if you wanted. Okay, let's simplify this. Hey, look, minus 2 square root of 5i plus 2 square root of 5i. That's handy. Those cancel out. Okay, is that a coincidence? It is not. That always happens if you multiply a complex number by its complex conjugate. Okay, so now we get 4. I'll change this. So this is going to be -1. So minus -1 becomes positive, and these together just become 5, and that's just 9, which is such a friendly looking normal number, right? The imaginary part went away. These two middle terms canceled each other out, and this I squared term becomes -1, okay? This always happens if you multiply a complex number by its complex conjugate. It changes from a complex number to a real number, okay? Very convenient because complex numbers can be kind of weird, okay? All right, so how could this be useful? Well, let's talk about dividing complex numbers. All right, what if we want to divide 2 plus 5i by 4 minus I? Okay. So let's do this problem. Divide 2 plus 5i minus 4i. Okay, so let's look at what this would look like. We have 2 plus 5i divided by 4 minus I. Okay. Do you know what to do? I don't really know what to do either because there's a complex number in the denominator, and I don't know what to do with that. I wish there wasn't. If only there was a way I could not have a complex number and just have a real number instead. Is there anything I know that can do that? Hey, what if I multiply by the complex conjugate? That's a good idea. What's going to happen? If I multiply a complex number by its complex conjugate, it becomes real. The imaginary part goes away. That'd be awesome because then I just have just a real number in the denominator. Okay, so now I got to multiply these out. 2 times 4 plus 2i plus 20i plus 5i squared, right, in the numerator. And down here, I'm going to have 16 plus 4i minus 4i minus I squared. Okay, this is looking good. These cancel out. The middle terms cancel out. If they don't cancel out, you're doing something wrong. You either found the wrong complex conjugate or you multiplied them wrong. Okay, so let's simplify the top a little bit. We're going to get 8 plus 22i minus 5 over, let's see, 16 minus I squared is going to be plus 1, right? Because I squared is negative 1. Okay, so I get 3 plus 22i divided by 17. Still has to have a fraction here, but here's the last step, is I write each of these, I write the real part just as 3 over 17, and then I write the imaginary part as 22 over 17 times I. And that's in standard form. Okay? So what did I do? I multiplied the top and the bottom by the complex conjugate, multiplied it out carefully so I don't make any sign mistakes, simplified, and then I just divided that real number in the denominator into both parts of the numerator, right, to get this in standard form. It has a real part and an imaginary part. So there's a little summary here. First, write the division problem as a fraction, then determine the complex conjugate of the denominator, multiply the numerator and denominator of the fraction by the complex conjugate of the denominator, and then simplify. All right, so that's how you multiply and divide complex numbers.